And welcome to this new video on functions. So functions is a mathematical concept that has a strict definition, but we are going to look at it in this video from a more dynamic perspective, which means how that is actually used in problems. So think of functions as a mechanism to signal a definite output for a given input. For example, the function is usually written as f of x is equal to something. Let's just say f of x is equal to x plus 1. Over here, x would be the x over here, this is our input, and based upon whatever input we give, this function f of x is going to produce a value which we will term as the output. So the set of all the inputs forms what is called as the domain, and the set of all the outputs forms what is called as the range. Uh, Now when we define a function, there is a third set which is called the codomain, but we will not be going into this. So today we will see the domain and range of a function. We won't be talking a lot about codomain. Alright, so this is just a linear function. You can see that this is x plus 1. By the way, I'm using a graphing tool which is freely available, and you can also download it. It's called GeoGebra. F of x is equal to x plus 1 is our function currently. So over here x can take any input, and corresponding to that there will be a definite output. Let's also consider some other function. So we will say the next function, let's call it g of x. I mean, it can be named anything. You can call it h of x, y of x, or for that matter even x of x. uh, let's say g of x was the function x square plus 1. Alright, and I'll just get rid of the f of x for the sake of simplicity. Yeah, so this is our function g of x equals x square plus 1. Now you can see that the domain of this function, which basically means what all values can be put as input, is pretty much all the way from minus infinity to plus infinity. Now it may not be clearly visible because the graph is somewhat steep, but you can put in any value of x and get a definite output. Alright, so over here we will see that the domain is equal to real numbers because we can put anything for x, so all the inputs are possible, but the range will only be the numbers that are equal to or greater than this value, which is basically 1, which we will get when we take the input as 0. So we can say that g of 0, how we usually write it is that we say g of 0, that would equal to 1. We substitute 0 for x and we get the value as 1. So this is another type of function. This is a quadratic function, and based upon this you can come up with any sort of combination of quadratic, cubic, linear and all these functions, till the time you are dealing only with functions that have x square, x cube, which basically means only whole number exponents of x. We will call these functions as polynomial functions. Let's take some more examples. Say h of x is equal to x cube plus x square plus 1. All right, and I'll probably delete the previous graph. Yeah, so this is now our function. You can see that this is going, the inputs can be anything from minus infinity to plus infinity, and it looks like this function is extending all the way on the y-axis from minus infinity to positive infinity. So the domain becomes real numbers and the range becomes real numbers as well. As a rule of thumb, you can take that if the leading term in a polynomial coefficient, if that term is of an odd degree, the range of the function will be all real numbers from minus infinity to plus infinity. It is actually pretty straightforward. I mean, if you were to put x as minus infinity, then x cube is also a very large negative number, and x square and 1 actually fade out in comparison to x cube whenever x is very large. So if x is a very large negative number, that means x cube is tending to minus infinity. So x cube is going to bring this whole graph, way down towards minus infinity over here. And if you take x as positive, this value is going to shoot up all the way up to plus infinity. The difference comes when the leading term has an even degree. So for example, let's just add an x power 4 to this and see the graph. Just a minute. Yeah. So you can see that the curve no longer goes all the way from minus infinity to plus infinity on the y-axis. These are polynomial functions, so you can always put any value as an input. So the domain of a polynomial function will always be real numbers by definition. On the other hand, the range may not be real numbers, because you can see if the leading term over here, we mean by leading term, I mean the term that has the highest power of x. In this case, it is 4. Since this is even, so if you take x as minus infinity, x power 4 is going to be even. I mean, x power 4 is going to be positive. Or even if you took x as positive infinity, x power 4 is still going to be positive. So it doesn't matter whether you're considering x as minus infinity or plus infinity, x power 4 is always going to make it a large positive value. In fact, any even power of x is always going to do that. And that is why we say that for such functions, the range will not be real numbers. Okay, that's it for this video. I hope you have enjoyed it. Thank you.